Yes, welcome you all for another presentation on operational amplifiers. In today's presentation also, I would like to explain you another very important example or model question on a operational amplifier, right? So let us see this given operational amplifier circuit, right, in which you are asking that find out the output voltage V naught for the following circuit. So this is the given circuit actually. Okay, so for this circuit, two input supplies are connected. One is 6 volts that is connected to the minus terminal, as well as 4 volts is connected to the plus terminal. Means for both the input terminals minus and then plus, correspondingly two power supplies are connected. With these two power supplies, now you are asking that to find out what is V naught, what is output voltage V naught. So how this can be solved, how we can solve this? So this is again very interesting, very important model, very important model, and very easy also. So let us think how it can be solved, how the V naught can be. So basically, in order to solve this particular circuit for finding the V naught, there are two methods are there. We have two methods. There are two methods in which you can solve this problem actually. Okay, the first method is direct method. So the first method is direct method only. What is that? Direct method. What is the direct method? First is the direct method, and second it is the superposition method. By applying superposition principle, because as we have two power supplies, there we can use superposition principle. First we see the direct method. This is the direct method. So by using the direct method, we can directly solve the value of V naught, right? What is direct method? Very simple. Okay, in method 1, let us see that at the terminal plus, what is the voltage connected? 4 volts. Means that whatever the voltage applies at this plus terminal, directly the same voltage 4 volts appears here also according to your virtual ground concept. Okay, at this particular point, the same voltage 4 volt automatically appears here. Therefore, let us see that, so in this arm, means in this resistor, assume that current I is flowing, the same current flows from here also. The same I flows from here to through this resistor and reaches to output actually, it reaches to output, right? Therefore, at this particular node, if you apply your KCL, means that this is the entering current at this node, this is the leaving current from this node. Therefore, at this particular node, if you apply the KCL, then definitely how it can be written? 6 volts minus 4 volts means 6 minus 4 by what is the resistance? 4K. This is the current value V by R form. Okay. So this is the value of I, nothing but entering at this particular node, is equal to leaving current. What is the leaving current I expression? It is nothing but, what is that? 4 minus V naught. It is 4 minus V naught, is it not? Here the voltage 4 volts. What is the output voltage? V naught. Means 4 minus V naught by 10 kilo ohm. By 10 kilo. So K gets cancelled. This implies 6 minus 4 is 2. It is 2 by 4 is equal to 4 minus V naught by 10. 2 ones are, 2 twos are, 2 ones are, 2 fives are. This further is equal to, so if you take LCM, means 5 is equal to, it is 1 only, 1 into 4 minus V naught. 4 minus V naught. This implies, what is your V naught? V naught is equal to 4 minus 5 is equal to minus 1 volt. Therefore, what is your V naught? Minus 1 volt. This is the answer. V naught is equal to minus 1 volt. Clear? That is using your direct method. V naught is equal to minus 1 volt. Using direct method. Direct method is nothing but directly applying by your virtual ground concept. That is first method. According to first method, answer is minus 1 volt. I think you understood this. Now coming to the second method. Coming to the second method. What is the second method? Second method is nothing but, again it is quite simple. It is not at all difficult. It is using your superposition principle. What that principle says? What the principle says? So superposition theorem states that if two power supplies are being used in the circuit, then at a time consider one power supply while making the another two 0 volts. You make the another power supply 0. Now using your second method, this is method 2, second step, okay, or second method I am solving for, right? According to your second method, so let us consider the voltage V1. Let us consider 6 volts. With respect to 6 volts, the corresponding V0, now you can consider it as V01. V01. So V01 is the output voltage with respect to 6 volts. Okay. So if you consider the 6 volts, make the 4 voltage to 0. 0. You must equal to 0 volts. You must connect it to 0 volts. Therefore, if you consider the 6 volts, then definitely you must make it to 0 volt. Directly you should make it to 0. That's it. It is some 0 volt. You must make it 0. Is it not? Like that. So, okay. Then definitely, then what is your V0? Then V0 becomes V01 is equal to, then obviously if plus is grounded here, then minus. So this is nothing but what? Tell me. This is nothing but your inverting amplifier. It is inverting amplifier. Therefore, in inverting amplifier, what is the output expression? What is the voltage gain, or what is the output? Output is nothing but simply it is minus RF by R1. Is it not? Into V in input. Clear or not? So if you make it 0, then it becomes inverting amplifier. In inverting amplifier, output is equal to minus RF by R1 into V in. And if you remember, V0 by V in means the voltage ratio, output voltage by input voltage is equal to minus RF by R1. This we have seen in the previous presentation. Or otherwise V01 output voltage is equal to minus RF by R1 into V in. So according to this formula, this is equal to minus, what is RF? It is 10 kilo by what is R1? It is 4 kilo into what is your input voltage? 6 volts. Clear? KK gets cancelled. 2 2s are, 2 5s are, 2 1s are, 2 3s are, 5 3s are 15. Therefore, minus is there. It is minus 15 volts. Minus 15 volts. What is that? Your V01. V01 is equal to minus 15 volts. Right? With respect to your 6 volts. Now, consider the 4 volts actually. Now, consider the 4 volts. Means that now you can connect here the 4 voltage source here, 4 volt. Then you make it to 0. Consider this one is 0. You make this to ground actually. You make this one as ground. Therefore, assume that with respect to 4 volt, now you can say that your output voltage is some V02, let us say. With respect to 4 volt, okay, output is V02. Now, what we are doing? Now the input is applied to the plus terminal. Now it becomes non-inverting amplifier. Is it not? Now it becomes non-inverting. Previously inverting amplifier. Okay. Now it becomes non-inverting. So in the non-inverting amplifier, what is your V0 actually output? So my V02 is equal to, directly if you remember that formula, 1 plus RF by R1. Clear? 1 plus RF by R1 into input. Clear or not? I think it is clear. So in non-inverting amplifier, directly you must remember the formula, 1 plus RF by R1 into V in, or otherwise the voltage gain V0 by V in is equal to this, what we have seen, right? Therefore 1 plus, what is your RF? The same, 10 kilo by what is R1? 4 kilo. Clear? Into what is input? 4 volts. It is 4. Therefore KK cancel. 1 plus how much it is? 2 2s are 2 5s are 5 by 2, nothing but it is 2.5 into 4. How much? It is 1 plus 2.5. It is nothing but 3.5 into 4. How much? It is 4 5s are 20, and then now obviously it is 14 volts. It is 14. What is this? V02. Your V02 is equal to 14 volts. Understood? V02 is equal to 14 volts. Now, what is my overall voltage? Now, your V0 is nothing but it is V01 plus V02, means V01 is the output voltage with respect to 6 volts input power supply, and V02 is nothing but output voltage with respect to 4 volts. Clear? So, if you sum these two outputs, then you will get the final output. What is V01? It is minus 15 volts plus what is V02? It is 14 volts. So, minus 15 plus 14 minus 1 volt. That is what your, see, this is the second method. Clear? So, in the first method also you got minus 15 volts, output as minus 1 volt, and according to your second method also using superposition principle you got minus 1 volt. Therefore, this type of problem is also very, very important in competitive examination, especially in GATE as well as UPSC's engineering service examinations, even UGC NET also. UGC means it is University Grants Commission, and NET, National Eligibility Test, exclusively that is conducted for JRFs, Junior Research Fellows, like that. Okay, so remember that this is very, very important model. I hope you understood this concept and you understood this problem, right? So please give your observations and comments and suggestions on this video or these ongoing topics, so that it will be very much useful for me to improve the video and the content of the video especially. And definitely do not forget to share these informations, very, very valuable informations, to your friends and colleagues wherever they are, so that most and majority of the students community should get the 100% benefit from these presentations, right? With this, I finish off today's presentation, and we will meet in the next subsequent presentation. Okay, thank you for watching the video. Have a good day.